Hi dear developers. In this video I'm going to talk about R programming language. Stay with us until the end of the video. What is R? R is a popular programming language used for statistical computing and graphical presentation. Its most common use to analyze and visualize data.
R provide a wide variety of statistical, for example, linear and nonlinear modeling, classical statistical tests, time series analysis, classifications, clustering, and etc., and graphical techniques, and is highly extensible. Why use R? For these reasons, we can use programming language like Python. But why we use R? R is a great resource for data analysis, data visualizations, data science, and machine learning. It provides many statistical techniques, such as statistical tests. It's easy to draw graphs in R, like pie charts, histograms, box plot, and etc. It works on different platforms: Windows, Mac, Linux, and it's open source and free. And a very important reason, it has a large community support. To get started with R, stay with us until the end of the video. And don't worry, it's not necessary to have a prior programming experience. To start using R and learning it, you must install the R on your PC, Windows, Mac, or Linux, and install an environment to use R. The first step is go to this website, cloud.rproject.org, and download R for your operating system. I use Windows. Download R for Windows and download the base library. Here we can download the latest library. It's about 18 megabytes. Next, we have to download the environment for using R. I use RStudio. You can search it RStudio and follow the download page. You can download it here for your using operating system. Download started. I have downloaded the both files. Now you must install R on your PC. Select your language. Finish. Next, you have to install the RStudio too. Now open your RStudio software just installed, and we have a environment like this, and the console to write the R statements here. At the beginning, let's test the famous Hello World example for R. No need to type print, echo, or syntax like this. Just a hello world. Here's the output. You can use a quotation or double quotation like this. Hello. It was the output for the strings. For output the numbers, just type their numbers without quotation. 5. Very simple. or like this. Now creating variables in R. Variables are containers for storing data values. As you know, or if you don't know, a programming language has a command for declaring of a variable. But R does not have a command for declaring a variable. And a variable is automatically created at the moment you first assign the value to it. For example, I want to assign a string value to a variable. Like this. Just type the variable and this sign and declare the data. For example, David. Now the name is David. Or another example, to assign a number, for example, integer value, age, for example, 25. And we can get it by the typing its name. Name David. Or age, like this. Another example. For example, first name, for example, David, last name, example, Jones. It's an error. Why this error occurred? Because of this space, I had a mistake too. We can't use space across the variable name. I must use it like this. Last name, Jones. I want to concat the first name and last name and print it. I must use the function of R. For this reason, use the paste function. Paste what? First name, last name, David Jones. It concat of the two string variables shown here. And for the numeral variables like this, for example, x1 is 4 and x2 7. You can use like this: x1, x2 is 11. But can't use operators for numeral and string variables like this. First name is cause an error. Non-numeric arguments in the binary operator. This is the binary operator, and this variable is non-numeric argument for this operator. It's caused this error. And like the above, we can assign variables to each other. For example, x1 this statement assigns the data in the x2 into the x1, and the result is x1 is equal to x2 and its last data will be erased. x1 was 4, and with this statement x1 as the new data of 7. And the important notice variable names are case sensitive, and x1 is different from the that x1. Object not found. And I can assign a different data to the uppercase x1, for example this. In programming, data types is an important concept. Variables can store data of different types, and different types can do different things. In R, variables do not need to be declared with any particular type, and can even change type after they have been set. This option is not available in many programming languages. For example, the family of C, C++, Objective-C, C# can't do that, but it's available in R. For example, again x1. It has a numeric data, and now I want to assign a string data. For example, John. Now the x1 is John. See below? Here I want to introduce some of the data types using in R. Click on this eraser to erase the console. First is the numeric data types. For example, x. In numeric data type, it can be, for example, 2 or x 4.5 and etc. Integer value, double datas, and like this. Second data type is integer. Integer data types like numeric but with a difference. For L. The character L at the end of the number declares the data type of this variable is integer. The next data type is character. Character-based data types, as you know, like a string. R is for checking the data type of a variable, we can use a function of R. Name it class of x. It's logical. Or define other data to x. For example, now again, it's complex, like this. Or z is 6L. Now answer the result of this function in your mind. What's the output? The class of z, 6L, must be integer because of this L. Again, define the data to z, just 6. Answer this function's result on your mind. Is it again integer? 6, and here again 6. But the result is numeric because we don't type the L in the last of the 6. R has many built-in math functions that allows you to perform mathematical tasks on number. For example, the mean, minimum function and max function can be used to find the lowest, highest numbers in a set. Or sqrt returns the square root of a number, or abs, so the absolute value of a number, and etc. For example, ceiling, floor. I want to introduce some of them here for you. For example, the mean function. Mean function of For example, 5, 6, 9. Mean was 5. Can use with arguments of the variable. For example, x1 is 7, x2 is 9, and x3 define 70 to it, and max of x1 and x2 is 9 is x2, or max of x1, x2 and x3 70. It's extendable to many arguments as you have. And in the string values you can define a multi-line data to it too. For example, str1 is clear the console. Here's str1. Here you can see these characters that added to our string, \n, \n, and here. These are stands for to go to next line. \n means enter in a text or new line. If you want to see this data without this \n and the R insert a enter or new line for these characters, you can use the cat function like this. Instead of \n characters here are inserted a new line. Now, how we can find the length of this string? How many characters had it? You can find by this function, nchar of str1, 123. Or another example, nchar of David, 5. 1, 2, 3, 4, 5. So length of how many characters have this string. Another function. First, I determine another string like this. Sorry. Hello, rapid coders, developers. How can I know that string str2 contains a specific character or word or not? For example, I want to find out if the str2 contains rapid word inside it or not. I must use a function to find out it. Here is the usage of it. Grapple. The phrase is our pattern. I want to find what word or character. Rapid, and the next the string I want to search inside it. True, it's contain rapid. Another example, is it contain X character? False. It doesn't have X character inside the str2 string. The next data types are booleans, as I introduced them a few seconds ago. True or false. Is the 4 is greater than 6? False. Is 7 greater than 6? True. Here's the simple usage of booleans. Is the x2 is greater than x1? True. x2 is 9, x1 is 7. Next, I want to introduce the operators in the R. The first and simple one is addition operator. 2, 4, 6. And they are very simple. And the multiplication or this and the exponent operator and this operator stands for remainder of a division. For example, division of 9 to 3 is 3 and the division is 1. Division of remainder of the division of 26 to 5 it's what? Answer it. It's 1. 5 to 5 or 25 and the 1 in addition to 25 is 26 or remainder of division of 27 to 5 is 2 and the division of 27 to 5 is this. And to find the integer part of division result we can use this operator like this. It's 5 34 and the operator is like this. Is 8. The next topic we're gonna talk about is the conditions and if statements in R. R supports the usual logical conditions from mathematics. For example, equal, not equal, greater than, less than, and etc. And the next topic is the if statement. An if statement is written with the if keyword and it's used to specify a block of code to be executed if a condition, the if condition is true. For example, we have two variables to test the if statement. x1 is 10, x2 is 11. If, here we write the condition, if x1 is greater than x2, to go to the next line, hold shift and press enter. Here is in the brackets, we write the code that want to execute if this condition is true. If x1 is greater than x2, this code will execute. x1 is greater than x2. The x1 is not greater than x2, so this code will not execute. Use the up key in the keyboard to access the last command. We can use the else keyword to execute if this condition is not true. The else brackets inside codes will execute. So here x2 is greater than x1. Now run the code. x2 is greater than x1 because the x2 is 11 and x1 is 10. So the else condition will be executed. We can specify one or more than one conditions in the if statement. For example, if x1 is greater than 5 and the ampersand stands for and in the conditions, and x2 greater than 5, then write the code here. Both greater than 5. Two statements are checked and both of them are true. x1 and x2 both are greater than 5. In other example, we can use the or. If x1 greater than 5, or this symbol stands for or x2 greater than 5, then do this code. At least one of conditions are true. If I use this statement like this, x1 is not greater than 20. So this condition is false. x1 is not greater than 20. But the x2 is greater than 10 because it's 11. This code will execute because the one of the conditions are true, because we use the OR symbol. Sometimes we need to execute some code more than once. In these situations, we must use loops. For example, while loop or for loop. Loop can execute block of code as long as a specific condition is reached. Loops are handy because they save time, reduce errors, and they make code more readable. R has two loop commands, while loops and for loops. First, we will introduce you a while loops. While loops can execute set of statements as long as the condition is true. Here is the example of using while. First, define a variable. For example, I is 1. And type the while keyword. While here's where we can define a condition for using while. While I is lower than 5, execute this statement. Print I. Next, increase I one step. When until this condition I is lower than 5, this code will execute it one by one. It will print the I and increase I. And increases the I. Run it. 1, 2, 3, 4. Why the 5 result is not in our results? Because first the I is 1 and is lower than 5. It prints the I is 1, then increases the I. Now the I is true. 2. At the next 2 is lower than 5. It will print the 2 and increase the I is 3. 3 is lower than 5, prints 3 and increase the I. Now the I is 4. 4 is lower than 5, printing the 4 and increasing the I. Now the I is 5. But in this condition the 5 is not true. 5 is not lower than 5. 5 is equal to 5. And this statement will not execute when the I is 5 and will not print the I to the screen. With With the up button on your keyboard, repeat the last statement and I will change the condition to 10. When I lower than 10 prints I. How we can break the loop inside the code? My condition is when the I is lower than 10. But I want to break this loop when the I is 7. I can use the if statement here. If I equals to 7, simply type the break statement. This loop will execute while the I is lower than 7, because if the I is 7, it will print the I because the 7 is lower than 10 and prints the I and increase the I, yeah, and if I is 7 it breaks. Actually it prints the 6 and increases the I and I will be 7 and breaks. This while will print the I until the 6. 5, 6. It not printed the 1, 2, 3, 4 because the at the last code I was executed the I was 4 at the was the 5 at the last while I have used. I used the increase it to 5, I to 5, and here we have the 5 and 6. We have no result. Why? Because the I was 20 and at the last loop it was changed. Again define 10 to I and re-execute the last code. The last I was 70 and runs it and skip the while. The next loop I will introduce you is a for loop. A for loop is used for iterating over a sequence. Here the loop is less like the for keyword in other programming languages and works like an iterator method as found in other object-oriented programming languages. With the for loop you can execute a set of statements once for each item in a vector, array, list, and etc. Here is a very simple example for loop in R. For x in 1 to 10, do this, print x. For loop is different from while. Here you can see it's define a variable named x and defines this data to x automatically. For example, 1 and execute this statement. Next, it will increase the x. X will be 2 in integer format. Then execute until the 10. Now you can see the x value here is 10L. You remember I said the L will be used in integer formats. And 4 is very usable in lists. A very simple list example I will introduce you. For example, names list. For example, students. Here's the list. Students list. There's David, John, Bob, and Alice. Sorry for my mistake, I opened brackets. It's because of using C# inside. My list of students here defined. Now we can write a for statement for using this list. For example, std in students. For each student in the list of students, do this, print std. For each std in the list of students, it will print the student name. Like the while loops, we can use the next and break statements here too. It's like while loops. The next topic I want to introduce you is R functions. A function is a block of code which only runs when it's called. You can pass data known as parameters into a function. A function can return data as result. To create a function, we must use the function keyword. Like this. For example, sqrt function With this statement, I define a function to a square RT function and define the function statements here. When the function is called, these statements will be executed. For example, print function called. With this code, I define the function with the name of sqrt function. And we can call our function like this, with typing the function name like this. The sqrt function is called. When you call the function, the statements inside the brackets of call function will be run like this. In the function statement, name the arguments. For example, num. And inside the function, you can use the num. For example, this sqrt function can use sqrt of num like this. When you call the sqrt function 2, I forgot the parameter sqrt function, and here we must define the parameter that using for this function. For example, 81. Sqrt function is called, and the next statement will print the sqrt of a function 9. Functions also can return a value as a result of a function. For example, my func is function function with two parameters, x and y. Or another example, my function 2 that return x divide to y. Now call the my func and define the parameters. For example, 10 and 2. Print my func 2 as parameters 10 and 5. The result is 2. Why? The print the return value of my func with these parameters. This function with these parameters will return 2 as result, and print function will print the returned value is 2. We can use parameters as nested in each other, like this. For example, print my func and parameters, and the first parameter is a returned value of another function. For example, my func2 of 104, comma, and my func2 of 150. It will print what? First, these functions will execute and return a number as result, this and this function, and the results again sent as parameters to this function. It's called nested functions. These functions returned value is 25, and this function's returned value is 5, and 25 and 5 are sent as parameters to this function, and the result is 5. Function recursions. R also accepts function recursions, which means a defined function can't call itself. For example, my new function can call itself. Recursion is a common mathematical and programming concept. It means that a function can call itself. This has the benefits of meaning that you can loop through data to each result. Increasing, for example, a number. A function will increase it with a random number, and recursion will call again the result of the last function. The developer should be very careful with recursion, as it can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. However, when written correctly, recursion can be a very efficient and mathematically elegant approach to programming. But to a new developer, it can take some time to work out how exactly this works. Best way to find out is by testing and modifying it. You can test its recursion with the random functions and find out how it works. And don't go to a trap of never-ending recursions. Here is a very simple function to know about recursion and never-ending loops. First, I will define a new function. For example, is5 is my function's name. function with a one parameter named x and open a bracket. Now I will define my function statements like this. If x equals 5, print is 5, else do this. Decrease the x one step like this. New x decreases by 1. Then again calls the is5 function with the same parameter x. This function accepts the parameter as x. If x equals 5, the function will be ended and printing is 5. Else decreasing the x and call the same function again. Now define a number to the x, or call the function without defining parameter but defining a number. It's 5, 10. I'm calling the is5 function with the 10 parameter. The result is 5. 10 is not 5, but y is printed. 10 goes to this function as parameter, it's not 5. This code will be executed, decreasing the x and calling the is5 again with the number 9, and again runs it. At the next step and the next recursion, it will call the is5 with 8, then 7, then 6, then 5. And when the x decreases to the 5, this code will execute and all of the functions that called in recursion statements will close and print it. If I call the function with other parameter, for example 4. 4 is lower than 5 and it's not 5, and this statement will execute it, and the parameter will be goes to 3, then 2, 1, 0, and etc. And the parameter will never goes to 5, and this is the never ending function. The stack usage is too large, close the limit, because the recursion never ending in this stage. This is a programming trap that I said before. Dear developers and rapid coder friends, The R language fundamentals was ended in this video. At next videos, I had talked about R data structures and R graphics and R statistics. You can watch them, and if you have any questions about topics that described in this video, you can comment us and I will answer all of them. Thank you for watching this video. I love you.